Hi everybody, today we're going to talk about inverse functions. Inverse functions reverse the actions of a function. Our notation is going to be f, and it looks like an exponent of -1 times x. And I don't want you to think about this as a regular negative exponent. So we do not mean here that f inverse of x is 1 over f of x. That is not what this notation means. So it's just this little way for us to tell that we're talking about inverses. Something really important is that if xy is on the original function f of x, then yx will be on the inverse function. So you see that reversing of the function from the very start. Here's really what we have going on. So we're starting over on the left with a domain of f, and we have a function that maps x over into y. So we have a domain of f, we have a range of f. Then f inverse comes along. Its domain was this range of f, and we send everything back to where it started. So it's very cyclical in its operation. We send something over, we send something back. As an example, think about this. If you can buy 10 gallons of gas for $42, then $42 buys you 10 gallons of gas. So I can see if I know how many gallons I want, I know the price it's going to cost me, or if I know the price that I want to spend, I know what I can buy. Not all functions are going to have inverses. What we need is a one-to-one function. So a function is one-to-one if and only if f of a equals f of b means a equals b. What this really means is that every x has only one y, so we're not going to allow any repetition of y when we look at a one-to-one function. The easiest way to see that is with the horizontal line test. A function is one-to-one if any horizontal line drawn on the graph intersects the function in at most one point. So let's take a look at a few graphs. So this first graph, which is really just x cubed, if we look at it, do we think it's one-to-one? So I want you to imagine drawing some horizontal lines, and you can see that they're only intersecting the function in one place. So this says, yes, this is one-to-one. If I look at this graph, which is x squared, I can see immediately that it crosses in more than one place. So this is not one-to-one. That does not mean we're getting rid of parabolas. Like, that's not going to happen. What we'll end up doing is making some restrictions on the domain of the function that we can make the function one-to-one. So let's look at this graph. Kind of curves up to the right. Again, draw some horizontal lines in there, and it says, yes, this is a one-to-one function. This one is absolute value, and hopefully you see this has the same problems that the quadratic had, is that it has a lot of repetition, so this is not one-to-one. F of x has an inverse function, f inverse of x, if and only if f of x is a one-to-one function. That's what we just said. Another piece that's important is when I take the compositions of the function and the inverse, in either order, I always come back to x. So if I take f composition f inverse of x, I get the same as if I do f inverse composite f of x, and I should get back to x. Again, think that circular motion. So let's start by just finding a few values, then we'll build up into finding the inverse functions themselves. So let's say we were given f of 5 equals 11. Then that means f inverse of 11 should be 5. So it's forward and then backwards. Same thing, if I know f inverse of 4 equals 6, then f of 6 should be 4. So this one's a lot bigger. I have a big chart of values that say values of x, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then values of f of x, 3, 8, 6, 7, 0, 1, 2, 5, and 4. So we're going to find some values. So I'm going to start with f of 6. So I'm looking along the x's. I see 6, it goes to 2, so f of 6 is 2. The next one says f of x is equal to 3. So I want to look through the f of x values. I see 3, which says the x value is 0. I want you to see we could have also written that as f inverse of 3, which would be 0. So two different ways to write the same things. The next one says f inverse of 1. So I'm looking through the function values. I see 1, which says my x value is 5. And just again, to go through the different ways to phrase things, this says f of x is 7. So when f of x is 7, my x value is 3. And the last one says f inverse of x is equal to 2. So this time I'm looking through to see when would f inverse of x be 2, and that's when x is 6. So think about if I plug 6 into the f inverse, I would get 2 for my value. To make that a little bigger, let's look at two functions, f of x and g of x, and decide if they're inverses. How we're going to decide is we're going to do the composition, f composite g, and see if that's the same as g composition f, which gives us x. So f of x is 2x plus 4, g of x is x minus 4 over 2. So let's start with f composite g of x, which is f of g, which is x minus 4 over 2. F says whatever you give me, I'm going to multiply by 2. So I have 2 times x minus 4 over 2, and then I'm going to add 4. Well, the 2's cancel, so I have x minus 4 plus 4. The 4's cancel, and I have x. So with the f composition g, it looks good. Let's flip it over to g composition f. I have g of 2x plus 4. So this time I take the 2x plus 4, I subtract 4, and I put it over 2. Immediately the 4's cancel. I have 2x over 2. The 2's cancel. I just get x. So this shows me that these are inverses. Let's try again. This time I have f of x is 3x over x plus 2, and g of x is 2x over 3 minus x. So I'm going to start with f composition g, which is f of g, which is 2x over 3 minus x. So I take 3 times 2x over 3 minus x over 2x over 3 minus x plus 2. So everywhere it said x, I put in the value for g. Now this is kind of a big fraction, so what I'm going to do is I'm going to clear the fraction by multiplying by 3 minus x over 3 minus x. In the numerator, I can see the 3 minus x cancel, so I have 3 times 2x, which is 6x. In the denominator, I really need to distribute first. So I'm going to write 2x over 3 minus x times 3 minus x plus 2 times 3 minus x. So I have 6x still. The 3 minus x cancels in one place in the denominator. I have a 2x. Then I can distribute this 2. So 2 times 3 is 6 minus 2 times x is 2x. 2x cancels 2x. I have 6x over 6, which is x, so that looks good. Let's go the opposite way, g composition f of x, which this time says I'm starting with my f, I'm plugging it into g, so I have g of 3x over x plus 2. This is 2 times 3x over x plus 2 divided by 3 minus 3x over x plus 2. Just like the last one, I need to multiply by this denominator of x plus 2 over x plus 2. And again, the top comes out really nice. The x plus 2 cancels. 2 times 3x is 6x. In the bottom, again, I want you to think of distributing. So I have 3 times x plus 2. Then the x plus 2 cancels in the second piece, so I have minus 3x. This becomes 6x over 3 times x is 3x. 3 times 2 is 6 minus 3x. 3x cancels. 6x over 6 says this is x. And again, yes, these are inverses. So sometimes you can't really tell just by looking at the functions. We have to go through and do the steps. So the next part I want to do is graphing some inverse functions. And the key to graphing inverse functions is going back to when xy is on f, means that yx is on the inverse. So I'm just going to reverse the points. So I'm going to start here with negative 6, 0, and I'm going to change it to 0, negative 6. Then I have the point negative 2, 2. So this time I go over to 2, negative 2. And then the last point is 0, 3. So I change that into 3, 0. So now I'm going to do my best to connect the dots. So let's draw that, and it's going to extend up. Now these will cross somewhere. We're not exactly sure where, and that's okay. But I want you to see that reflection that's really happening. There is symmetry to the inverses, and what the symmetry is to the line y equals x. So when I have the graph of inverse functions, they should always look symmetric to y equals x. So let's try another one. Again, I'm just going to go point by point. So my first point I see is negative 1. It looks like about a half, so I'm going to go a half, negative 1. And then 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. And then my last 0.24 becomes 4, 2. So we are connecting these dots, and we kind of want it to have that same curve that we see in the original. And again, my graphing is not great, but you can see here's the opposite. So one more. This one starts at -4, 0. So I'm going to go 0, -4. Then I can see it's -3, 1. So I say 1, -3. 0, 2 becomes 2, 0. And then lastly, 5, 3 becomes 3, 5. Same deal, I connect the dots, make sure it's still a curve, and it's going up. Yes, it crosses, that's fine, and there's my line of symmetry if you want to gel it. So hopefully this is kind of easy, and you just think I'm going to flip xy to yx and connect the dots. So bigger than that, if we actually have a function right now and we want to find the inverse, we have these nice 4 little steps that help get us there. So step 1 is to replace f of x with y. So we introduce y into the function. After that, all the x's and y's switch. Anything that says y becomes x, anything that's x becomes y. Then you're always solving for y. So step 3 is the big step. And then the last step is to replace f inverse with x. There is this extra part that you have to do occasionally, which is restrict the domain of the inverse function to make it a one-to-one function. So I need to start with a one-to-one function, I need to end with a one-to-one function, and I'll show you what that means. So here's our first one, nice and easy. F of x is 3x minus 5. I start by saying y is equal to 3x minus 5. That's my first step. After that, I switch x and y, so now x is 3y minus 5. The big step is solve for y. So this is x plus 5 is 3y. Divide by 3, x plus 5 over 3 is y. Now you can leave it like that, or if you wanted to say this is x over 3 plus 5 over 3, you can do that. Like, it's really up to you. But I want you to kind of see at this point, I started with the line 3x minus 5. I'm ending with the line x over 3 plus 5 over 3. So 1-to-1 to start, 1-to-1 to finish. This f inverse, I'm going to go back and write it x plus 5 over 3, but you can write it however you like. So this is no reason to change anything. I don't have to restrict the domain. I have a line. It's already 1-to-1. So let's make it a little bigger. I have x cubed plus 2. Now x cubed is a 1-to-1 function. We know what the graph looks like. Immediately, I want you to start thinking, what's the opposite? Hopefully you're thinking like the opposite of a cube should be a cube root. So we're expecting a cube root as the answer. Even if my picture isn't good, but just in general, we can think of that. And I know 1-to-1 to start, 1-to-1 to end, so I don't have to think too much about the domain. Step 1 is put in y. So I have x cubed plus 2. Step 2 is to switch x and y. So I have x is y cubed plus 2. I want to solve for y. So I subtract 2. And then I take the cube root. Cube root, we already said, is a 1-to-1 function, so we're good. All we have to do is call this y f inverse. So f inverse is the cube root of x minus 2. Hopefully you start to see that the opposite is in the inverse. So the original function says add 2, the inverse says subtract. The original function says cube, the inverse says take the cube root. So you should see the little pieces and it should look good to you as you're going. The only part that you really need these 4 steps is where does that minus 2 go? Does it go inside? Does it go outside of this radical? So I like these little steps to make sure we don't mess it up. So here's one that does have a restriction. I have f of x is x minus 3 squared plus 6, and x is greater than or equal to 3. Here's what happened is f of x is x minus 3 squared plus 6. We know what that looks like. It's 1, 2, 3 over and 6 up. And it was a parabola, so think it went both ways. But this is not a 1-to-1 function, right? Like I can see it fails the horizontal line test. So what we do is we take half away. Now it's 1-to-1. So this is why we have this x greater than or equal to 3 from the start. You don't really do anything with that. It just has to be there to make it 1-to-1. So to find the inverse, I say y is equal to x minus 3 squared plus 6. I switch that to x is y minus 3 squared plus 6. I solve for y, so that means I need to subtract 6, and then I need to take the square root. When you take the square root, you don't put plus or minus because we're trying to keep it 1 to 1. So if I put plus or minus, that would be 2 answers. So none of that when we do inverse functions. Let's add that 3 over. So I have the square root of x minus 6 plus 3 is y, which says now the square root of x minus 6 plus 3 is f inverse of x. You don't have to change the domain. When you look at the square root function, and I'm not even going to draw this accurately, but I can see it's already 1 to 1. So let's try this bigger one. I have f of x is 2x over x minus 7. And we're not going to worry about the 1 to 1 part. We're just going to go with it. So we're going to say y is 2x over x minus 7. We're going to change that to x. Now watch this time. I end up with 2 y's. I have 2x becomes 2y. I have x minus 7 becomes y minus 7. So it's the first time I have 2 y's as I'm trying to solve. I need to solve for y, so let's get it out of the denominator. I'm going to multiply both sides by y minus 7. So that cancels. So on the left, I have xy minus 7x is 2y. I'm trying to solve for y, so that means we need to bring all the y's together. Let's say I bring them all to the left side. So I'm going to have xy minus 2y, and I'm going to push the 7x to the right. So I kind of just flip these two. The big thing, important step here, is factor out the y. So I have x minus 2 is 7x. This is important because we went from 2 y's down to 1 y. So when you have multiple y's and you're trying to solve, you have to factor somewhere. But then that means that we're almost done. That says y is 7x over x minus 2. So we've solved for y in terms of x. That means f inverse is 7x over x minus 2. So the next one says find a domain on which f is 1 to 1 and non-decreasing, write the domain in interval notation, then find the inverse restricted to that domain. So this is kind of like what we did earlier because we have this quadratic x plus 3 squared plus 4. So let's kind of just do a quick sketch of the quadratic. So here's our quadratic, x plus 3 squared plus 4, and it says we want to restrict the domain to make it 1 to 1 and non-decreasing. So it was decreasing here, so that's the part I'm going to get rid of, and I'm only going to keep this increasing part to the right, which starts at -3. So we're going to make x greater than or equal to -3. Then to do the inverse, I say y is x plus 3 squared plus 4. I switch the x and y, so I have y plus 3 squared plus 4. To solve for y, I'm first going to subtract the 4, so I have x minus 4 is y plus 3 squared. Take the square root of both sides, so square root of x minus 4 is y plus 3, and then simply subtract the 3. So this y now is my f inverse, so f inverse of x is square root of x minus 4 minus 3. Hopefully, what you start to see is the only time we have problems is really when we look at these square root problems. Let's do one more where the inverse doesn't come out 1 to 1. So what I'm going to do is I'm going to start with f of x equals the square root of x plus 1 minus 2. Now this is 1 to 1 to start because I know that the square root function is 1 to 1. So I'm going to put in y is equal to the square root of x plus 1 minus 2. I'm going to switch that to x is equal to the square root of y plus 1 minus 2. I'm solving for y, so I have x plus 2 is the square root of y plus 1, and then I square both sides. So x plus 2 squared is equal to y plus 1. Now, I'm not going to expand, I'm going to leave that how it is, and I'm going to do this next step of x plus 2 squared minus 1 is y. So I've solved for y, which says this is my inverse function. So you have a couple different ways that you can do the domain because we do need to restrict the domain of this inverse function. So one thing you could do is you could think about the graph of this. X plus 2 goes 2 to the left, 1 down. here's my vertex, and it goes up, and I want to restrict it, and I would say I only want half, so I'm going to get rid of the left half, and I'm just going to have the right, which would say x is greater than or equal to -2. Another thing you could do is you could go back to the original function x plus 1 minus 2, which went 1 to the left and 2 down, and it starts here at -1, -2. What you have to think is opposite. So when I look at this f of x function, the domain was -1 to infinity, and the range was -2 to infinity. So the range of the original function is equal to the domain of the inverse. So you see that kind of flip-flop there. So you could go that way too. So you do have two choices, which I like. It's really up to you, whichever way works best for you. Again, give yourself patience, go kind of slow, check your work as you go, and I think you'll do great. Good luck.